Good morning, everyone. My report topic is vertical distribution and migration patterns of Nautilus pompilius. And then first introduction of Nautilus pompilius, and they are capable of metabolic suppression in an axial and low temperature environments like in the deep sea. And it's an opportunistic feeder. Opportunistic feeder means it can scavenge dead bodies descending from the surface or preying on crustaceans such like shrimp or crab. And their movement pattern is vertical migration. And as you see in the right side, the organisms will migrate to a shallow water depth in the night when under the cover of the darkness, and will return to the dark depths during the days to avoid visual predators such as seabird or a dolphin or something shark. And this vertical movement pattern has been documented across these three primary population localities in Palau and Manus Island and Port Moresby. The data shows the Nautilus will stay in the water depth range is 200 meters to 250 meters to 300 meters in the daytimes, and their activity will prefer to resting. And when they go to the night, their migration into a shallow water is 100 meter to 200 meter depths, and they will change into feeding. And because of this result, the vertical depth migration into a shallow water at night is by Nautilus is first hypothesis in the early 20th centuries. But the result of this study shows there's indicate more one than patterns is present in the genus. And also this study has filled a research gap is the influence of habitat, substrate, and biota on the vertical movement of Nautilus has not been investigated. And let's talk about the study sites. The study site located on the North Australia, which called Osprey Reef. And the research group used two methods to record data. The first one is trapping Nautilus from Osprey Reef and track for up to 78 days. And sample number we have 10 mature males and 1 immature female. And the second one is use remotely operated vehicle to observation Nautilus underwater. And we have 48 individuals recorded, and 5 of them were juveniles. And as you see in the right, and we research group use the ultrasonic tagging to monitor the location and the depth. And this data will collect using activity board tracking and fixed underwater station to record vertical movement patterns. And here's the result. And this graph shows the vertical movement of tagged Nautilus with temperature depth profiles. And as you see in the right side, the 25 degrees Celsius is a limited biological limitation of Nautilus. And as you see, it's close to the 100 meters. So as you see in this side, and each different color lines means different tagged Nautilus individuals. And as you see, there's no activity above the 100 meters. And also the graph shows another result is unlike the previous research is previous result says that the Nautilus will migration into a shallow water at night. But as you see, when during the 0 a.m. to 6 a.m., the result shows the Nautilus will migration into a deep water depth. But in the daytime, during the 6 a.m. to 6 p.m., they will migration into a shallow water near close to the 200-meter depth, and it's differently from previous research. And also, the percentage of resistance shows the Nautilus in Osprey Reef prefer to stay the water depth above the 225 meters. And the resting time means any time greater than 15 minutes with less than 5 meter movements and with detection record within at least 15 minutes of each other. And this is a type 2 method and use the ROV dive profiles. And you can see each different color lines means different ROV dive sites. And each quota means recorded Nautilus individuals. And The result shows during the 6 a.m. to 2 p.m. The recorded nutters all prefer to stay in the depth water during the 500-meter depth to 700-meter depth. And you can also see the deepest one is almost over the 700 meters. And it also provides another different result is this group, these record individuals are all prefer to stay in the depth waters. So it also challenges the previous hypothesis. They don't not just they are similar with previous research is they will stay in the deep water depths during the daytime, but we have so it shows not just only one movement pattern. And here's a discussion about the biological constraints. And depth region restricted is shows by temperature is 100 meter. We just talked before. And depth is 800 meter is limited by shear impulsion. Shear impulsion means because of imbalance inner and outer stress, the water stress will squeeze the shell and make it explosion. So you cannot just dive under the 800 meters. And the discussion too is about the buoyancy mechanics. If the water depth is deeper than 250 meters, osmotic pressure will force water into the chambers. So nutters will get the negative buoyancy, it will be sinking. And if the water depth is shallower than 250 meters, the nutters can remove liquids from chambers. So it will get neutral buoyancy, which neutral buoyancy means you can floating in the water or stability. And here's the regional comparison. And Palo is the Purdue research site. As you see, it has a different habitat in the 200-meter depths. Osprey Reef is rocky reef, and Palo lacks shelter and hiding place. So and it also have different natural sites in Osprey and Palo. Osprey is small and Palo is large, so it causes the different survival stages. The nutters in Osprey Reef prefer to hide in the reef, and the Palo prefer to move low light area deeper than 300 meters. And also you can see it's the profile of nutters habitats. And A and B is the Palo, and C is Papua New Guinea. And as you see, A and B have a very similar habitat between and with D, but the different nutter sites cause the different survival stage. So the A and B nutters in A and B will prefer to migration into a deep water depth, just like a hypothesis. But in the Osprey Reef, because it's smaller, so you just can hide in the reef. So it's not a good choice for them to migration into a depth waters. And C, as you see, its habitat is deep, so it will be more convenient for nutters to migration into a depth water, not just hide in the reef. A comparison of food ability shows Osprey Reef in 100 to 250 meter depth. Its substrate type is steep and rocky, and its core rate is low. But in 300 to 450 meters, its substrate type is gradual salinity, and its core rate is higher than the 100 to 250 meters. And in Fiji, is close to 300 meters, and its substrate is muddy substrate, and its core rate is best. And New Caledonia, because it's a cooler habitat, so the water depth will be more shallow than the previous research sites. And its water depth is 50 to 75 meters. And its substrate type is talus near the reef wall. And its core rate is optimal. And this higher cost research site have in common is they are exposed areas, which means it can be more convenient for nautilus to its dead body descending from the surface or praying here. So the conclusion is the diurnal vertical migration of nautilus will infect by these three key factors. The one is preferred feeding habitat, just we talked in the previous page. And next one is buoyancy regulation, and we have already talked. And the third one is avoidance of visual predators. It will relate to the factor 1 and a factor 2. Okay, that's all.
Can you turn to page 10?
Okay. Yeah.
Can you explain the resting time again? Because I don't
Okay.
really understand.
They record by ultrasonic tag, right? So it will detection record within at least 15 minutes, and it need to be any time greater than 15 minutes without any less than 5 meter movements. So it will be so the research group will think, oh, it's resting time.
So I want to make sure what's the main purpose of the topic.
Because the main purpose is they want to challenge the previous hypothesis, and also because the hypothesis is also provide interesting interesting situation is that the Gilmore and Arthur will stay not well. It's not well. They will not divide the habitat in the water depths. It will, and it's a new discovery of Nautilus.
Can you go to next page, maybe 11? Oh yeah, can you explain what is the color square?
This one?
Yeah, why did they have different colors? What's the
Different
meaning?
color. Oh, it's just
Yeah.
a mark. It's the quota. It means individual, so they want to make sure not the same, and they will check. It's more easier for them to check. Oh, there's have an individual here, and just like this.
Oh, okay, thank you.
Okay, so as I mentioned again, next time please move your page number here. Okay, and then I think overall you did a clear and fluent presentation, but my feeling is actually when I read the article you chose yesterday, I think, wow, you have chosen a very nice presentation material. This could be very, very super interesting. Then today I feel that it could be more interesting. Okay, and especially I feel that you were too parsimonious, 就是太吝啬. You were too parsimonious in using images. You should use a lot of image of this cute creature to make everyone think, wow, it's so cute. Okay, so I can give an example. For example, there is an easy material here, and I'm surprised that you didn't use it. I'm super surprised, which is the deepest record of Nautilus eating a fish. Isn't that interesting? So if I were you, I would definitely use it and make the image super, super large. Okay? So you might think that you want to explain the scientific context. However, a good presentation should be both to interest people and also present the scientific context. So to achieve that goal, I will use as much image as possible. So for example, here you were trying to talk about this vertical migration pattern, right?
Yeah.
Then if I were you, I would make it really, really large because the impression of this background introduction was not strong enough so that the one of the students still asks you what is the purpose, and you say the purpose is to to validate or reject the previous hypothesis, right? So here I think you can use more time to introduce it well, and the best way to introduce it is to add a really large image, and you can make your little cute Nautilus swimming here, saying during the day they are doing here, and during the night they are doing here, something like that. To give people better impression, that would be much better than a table. Okay, so table is usually the worst presentation material. Okay. Don't use it too much, okay? And then there is a place I need to Yeah, for example, here I would say that this is, that's a result, right?
Yeah, it's a result.
Okay, so, yeah, that might be okay, but I think you should pay more attention to a very fancy introduction image
Okay.
than a lot of text. That's a little bit too wordy. Okay, and then here you have this, where is the place where you read juvenile? Okay, so by the way, if I were you, I would perhaps say more about this creature itself, because I don't know how you feel about this creature. This creature is very attractive to me, very mysterious and very cute with a very large eyes. So I would say more funny facts, 有趣的事实 about this creature to interest your audience. Okay? Then here you talk about, and actually later you says you have a slide where you emphasize this 25 degree. Did you say that here somewhere? 25 degree? Here? Where? Here? Is that a consensus? It's like a 共识 where that's the optimal temperature for the creature? Then it would be great to put it in introduction. Okay, to say, okay, this is what we want to test, their migration pattern and their optimal temperature, etc. To make them more impressed regarding the knowledge about this creature. Okay, and then this pronounced juvenile. I cannot find the slide. Juvenile, 就是幼虫呢, juvenile. Percentage of resting. Okay, percentage of resting. Here, please spend some. You were explaining this, but I feel that you have to explain this first. Explain this. What are this? And at the end, it turned out to be different depth interval, right? So say this first. Okay, and then here this, because here this figure has actually two kinds of symbol or line, and you say it. You say that the line is ROV track and the dots are Nautilus spotted, right? But it would be great to print some keywords, and especially I remember that when after you talk about these slides, you still say a lot more, a little bit like the discussion of the figure, but without any keywords printed on the slide. When you want to say a lot about your slide, you should print keywords. Otherwise, if you just blah 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 say a lot, their minds start to drift away. So keywords, always bring them back. Then here, I'm also surprised that you did not try to look for an image of implosion. It's so easy to find implosion of this creature. Look it up. There are image of Nautilus implosion. Poor guy. Okay. Yeah. And here you also say a lot. But because you talk too much, I lost my mind already. I don't really know what's the key point here. So if you want to discuss it, give us more keywords. Like this means steeper or what? Or this means steeper. Which one is steeper? You know. Okay. And then in your next presentation, please, I know that would be not that interesting to do it again, but try to emphasize that this paper also has the deepest spotting of Nautilus. It's actually cited by Wikipedia, so you should do that. Good. And how do you pronounce this again? Because it's a little bit blurry, so I was thinking, what is that? Nautilus. Okay, good. Thank you. Hope to see your improvement.